Data types are fundamentally important to programming. Having a clear understanding of how to use them and being capable of using them intentionally in your programs will help you write better code. When you write functions that have parameters of specific types, you can depend upon people giving you arguments of those types when they use your function. When you have functions that have a specific return type, whenever someone has a function call that uses your function, they can be guaranteed some data type in return. So it allows us to depend on the results and the data that flows through our programs. Sometimes we want to add additional names or aliases to data types that already exist. And we'll look at some simple examples of this. And as we look at complex data types that we're going to specify in the upcoming lessons, we'll see even better examples for why this is a valuable concept. But what we're going to look at in this lesson is how can we give an additional name to an existing data type through a type alias. Most problem domains that you're working in with programs are going to have very specific needs, very specific data types they're working with. If you're working with biology data, you're going to have types that are related to pairs of base pairs of your DNA, right? So a data type communicates what some values attributes are, what kind of data it holds, and what its capabilities are. So we know that there are things that we can do differently with a string than we can do with an integer. There are things that we can do differently and expect will behave differently with a floating point value than with an integer as well. When you have an integer, you know you can do arithmetic with it, right? So the types we've used so far have been built into the Python programming language. And we're about to get into a unit where we start looking at types that we invent and that we specify in our programs that weren't built into the Python language to begin with. So you're going to be writing in the future programs that need to model specific kinds of problems in more complex concepts than we've seen so far. And type alias are going to allow us to assign names to data types that are otherwise very broad. And we'll look at an example of this in this lesson, and we'll look at way better examples of this in the next lesson when we look at tuples and inventing our own data types. Soon we're going to be looking at composite data types. So far, when we've seen integers or floating points or booleans, we've looked at singular values, right? We've actually seen a preview of a complex data type that's built into the programming language, a string, and that's made up of many characters, right? We can have strings of arbitrary length, so these must be complex because you don't know exactly how big a string is when you're working with it until you have that data in front of you. So type aliases are going to allow us to give a contextually specific name to a type. And we're just adding an alias to that type. So the old type name still works, but we're inventing a new type name that we can use to mean the exact same thing. And I'm going to be straightforward with you here and honest and say that this example, when we only have floats and ints and bools, isn't a very strong one, but this will at least give you an example of how it works, and we can try this out in code in just a moment. So notice here that we're specifying a %, and this is a type alias. So this % is a variable that we're giving a special name to. A capital P is going to give us some hint that we're dealing with a type that we've defined ourselves. And we're just saying that's assign what float is. So it's now equivalent to what a float is. Once we've done so, we can use this % alias as a type. So notice in this next line, we're declaring a variable, coin toss odds, and we're saying its type is %, and it's being assigned initially 0.5. So we've established a % alias, and we've effectively invented a new type. Anywhere we could use a type, we can now use the word % to mean effectively an alias of float, right? Let's go ahead and try this out and convince ourselves that this comes together. So I would encourage you to set up a file in your lessons directory to follow along, and I've set up a doc string here. Assuming you've got this going, what we can do is we can go ahead and set up that same example. % is a type alias for float, right? And now I'm going to use a different example on the slides, and let's look at comparing two values and taking the percentage of, say, a numerator from a denominator, right? It's sort of like a ratio. And so I might define ratio as something that is given, let's say, two ints. We'll give it a numerator int and a denominator int, and it returns a %, right? And calculate simple percentage. So what we're going to do is we're just going to return numerator over denominator using the built-in division operator that Python has, and notice that this checks out. This works. If I had tried to return a string here, like hello world, we would see that expression of type hello cannot be assigned to return type %. So the type checking is still looking over our back and telling us, hey, you told me you would return something that was expressed as a percentage, and % is really just an alias for float, right? And this example would run if I wanted to try running it really quickly in my terminal. I can do that. So Python m and lessons.ls20 type alias is what I named that file. And we don't have any code to run this example. So what I'll do is add a main, right? So we'll use our main idiom here. So if name is equal to main, then run main. And let's go ahead and add a main function that will print the ratio of, say, 1/2, which is what we were looking at before. And this is a function, so we need to pass these as arguments. So ratio, where the first argument is 1, which will correspond to the numer parameter, and the second argument is 2, which will correspond to the denominator parameter, right? And so I'm going to go ahead and try running this again. Let me see if I can get this all. Might make this just a little bit smaller, see if I can get it all on one screen here. Great. And we run this again, and 0.5 is the result, right? So this isn't an exciting result. The point is, notice that we are defining a brand new type, but really what we're doing is we're aliasing an existing one. I'm gonna warn you that doing this with built-in types isn't encouraged. In fact, it's discouraged. You have to really be careful and sure of what you're doing to try and make use of an example like this. What we're about to look at though, and I want to plant the seed for giving you a reason to understand why it's important that we would want to be able to alias types, is we're going to import a special type called a tuple. And we'll look at what a tuple is in the next lesson, but I want to give you a preview here. So from typing, import tuple, okay? And a tuple is a sequence of values. So let's say we wanted a 3D point with 3 floats that are a part of it. Well, we can specify a type named point3D, and this is going to be an alias. And it's going to be an alias of a tuple type that has 3 floats. All right. Now, what can we do with a tuple of type point3D? Well, we could declare a variable of type point3D. So we'll say a point is a 3D point, and it's going to be the values. And the way that we're going to see in the next video that we construct a tuple is with some tuple literal syntax. Just like we've seen string literal syntax and number literal syntax, tuple literal syntax is going to be 2 parentheses, and we give these 3 numbers here. So I'll just say maybe 0.0, 1.0, and 2.0. Right? And let's go ahead and print a point. So I run this again, and notice that we've invented a type that's a tuple type, which we'll look at in full depth in the next video. And a tuple is made up of 3 float values, right? So a sequence of 3 values, and we've set up an alias. This specific tuple type we're saying is made up of 3 float values, and we're setting up an alias for that concept, a tuple that has 3 float values named point3D. And you'll notice that this tells us that it's a type tuple of float, float, float. If we highlight over %, you'll notice that this is telling us we've defined an alias of type float, right? So we have this ability to, and I might make a note here of this. So just for reference purposes, define 2 type aliases for with specific names for more general types. Okay. And you could imagine that, I mean, as we've seen, float can be used for many other purposes than to represent a percentage. And point3D is a tuple that's made up of 3 floating point values. And you can imagine that we could use 3 floating point values to mean something other than just a 3D point, something that has more specific meaning or different meaning than that, right? When you're defining these custom type names, such as point3D and %, You're going to name these differently than you would normal variables. So with normal variables in Python, we would use snake case. Here we're using what's called camel casing. We're going to begin the first letter of our type names with a capital letter, and then subsequent words, there won't be an underscore between them. We'll just recapitalize next words as we're seeing here. So capital letters is 2 words, and if we wanted to make this a camel cased name, we would just say capital C, capital L, notice no underscore between them, and so on, right? So in this video, we've briefly introduced the idea of a type alias. As we start working with compound data types, such as a tuple, they're going to be really important for making our programs easier to understand. Without them, notice we would have needed to type tuple ... everywhere we wanted to use that type in our program for our parameters, for our return types. But with type aliases, we're able to give a specific name to this kind of tuple and then depend on that name through our programs.